Now, let's move on to a new idea called differentials. Differentials helps us estimate how much a function changes. Suppose we have y equals f of x, and if we take the derivative, then dy over dx equals f prime of x. Now, if we multiply both sides of this equation by dx, we have dy equals f prime of x times dx. We call dy the differential. Let's talk about what this means. Dx represents a small change in x, and dy represents the approximate change in y. Now, here's the main idea. There are actually two different kinds of change: the actual change and the approximate change. The actual change is called delta y, and delta y equals f of x plus dx minus f of x. This is the exact change. Approximate change is the differential, which is dy. So dy is an approximation of delta y. And the reason we do this is differentials are easier to compute than the exact changes. Let's look at the graph to understand this better. The blue curve is the graph of the function f of x. The orange line is the graph of the tangent line. Start with the first x value, x equals a. I have this point a comma f of a. This point is on the blue curve and also on the orange line. The second x value is a plus dx. And a point on the graph is this point. The x-coordinate is a plus dx, and the y-coordinate is f of a plus dx. The difference between these two x values is the change in x, which is dx. If I take the y value of this point, subtract the y value of this point, which is f of a plus dx minus f of a, that is the actual change in y, which is delta y. Now, let's look at the second x value again. The point on the blue curve and the point on the tangent line are different. The point on the tangent line is the approximation of the point on the blue curve. So if I take the y value of this point minus the y value of this point, I get the differential, which is the approximate change of the y value, which is dy. The two values are very close when dx is small. So instead of computing the exact change, we use the tangent line to estimate it. Again, this works best when the change is small. Now, let's talk about how to actually use differentials in problem. Step 1, find f prime of x. Step 2, use the formula dy equals f prime of x times dx. Step 3, plug in the value of x and the value of dx. And that gives you the approximate change. So to summarize, dx is a small change in x. Dy, the differential, is the approximate change in y. And we use dy equals f prime of x dx to estimate how much the function changes. Now, let's apply differentials to an example. We're given y equals x squared plus 2x. We want to find both the actual change, delta y, and the approximate change, dy, at x equals 3 when dx is 0.2. Let's find dy first. dy is the differential, which is the approximate change. These three steps are used to find dy. Step 1, I need to find the derivative. F of x is x squared plus 2x, so f prime of x is 2x plus 2. Step 2, I need to use the formula dy equals f prime of x times dx. I replace f prime of x with 2x plus 2 and replace dx with 0.2. So dy equals 2x plus 2 times 0.2. Step 3, I need to evaluate dy at x equals 3. So from here, I will replace x with 3. So I have 2 times 3 plus 2 times 0.2. 2 times 3 is 6, plus 2 is 8. So I have 8 times 0.2. And 8 times 0.2 is 1.6. So I have dy equals 1.6. This is the approximate change. Now, I need to find the actual change, delta y. Delta y equals f of x plus dx minus f of x. X is 3 and dx is 0.2. So I will replace x with 3 and dx with 0.2. So delta y equals f of 3.2 minus f of 3. To find f of 3.2, I replace x with 3.2. So I have 3.2 squared plus 2 times 3.2. To find f of 3, I replace x with 3. So I have 3 squared plus 2 times 3. 3.2 squared plus 2 times 3.2 is 16.64. 3 squared plus 2 times 3 is 15. 16.64 minus 15 is 1.64. Let's compare the results. The approximate change is 1.6 and the actual change is 1.64. These are very close. Which is easier? dy is easier to compute because we only need the derivative and simple multiplication.